Okay, over the years, the modern day space elevator has matured from a bright concept in 1895 through a NASA innovation study with the growth to an idea that is now ready to start development. In addition, the concept has matured into one that leverages modern materials, space systems, communication strengths, and the concept of intermodal transportation. This new vision enables the development of permanent space access infrastructure, then will enable massive missions to be accomplished much more rapidly and safely. In addition, the modern day space elevator is truly the green road to space while enabling daily, routine, inexpensive infrastructure operations. Its strengths are transformational, leading to a tremendous customer satisfaction, such as 70% of the pad mass reaching geosynchronous altitude and 30,000 tons delivered to GEO every year. Now, these are goals for the future, but the options are limitless. As just an aside, I wasn't planning on talking about. Today, I was writing my paper for the IAC in September 29th or so in Sydney, and I came up with a new term, which is the apex anchor spaceport conducting planetary defense, terminal guidance, and destruction of asteroids. So there's a whole new mission for space elevators as planetary defense. And I think that's really kind of the way we're going, which is we create ideas as we go forward. When we see the strengths that space elevators provide, it just blows us away and we can come up with new missions and new ideas. And it's really remarkable. Okay, hey, thanks, Larry, for your little image there on the lower left. I think it's great. It shows how the space elevator works. Its centrifugal force keeps the apex anchor out there as it goes around the Earth. I always like to show the simple version of the space elevator, the Earth port, the apex anchor, 100,000 kilometers plus or minus. It really puts it in perspective. But then let's take it one more level. The perspective for us physicists and people look at the radiation belts around the Earth. Look at how long it is compared to the bow shock. People don't put the space elevator in perspective most times. What the heck's 100,000 kilometers, like 500 times around the Earth or something, but it's a long ways. And so I like to put it in perspective. Okay, let's look at what we're talking about in modern day space elevator. We've got a vision, we'll go into that. There are tremendous benefits from an infrastructure that we really haven't leveraged very much. We need to push pretty hard. And we've got my new favorite number, which is delivery of 70% on the pad mass to the geosynchronous. Now, a recent study that was done on the climber basically showed we could do 50%, but that's today. We want some reach out goals. So we're going for 70%. The image on the left is that dual space access, which I think is an extremely important concept. Let's not throw away rockets. We need them to put people through radiation belts rapidly. We need them to service low Earth orbit. We can't do that. So we need to work with the rockets. Our vision, if you go to our website, we have that vision. Space elevators are the green road to space while they enable humanity's most important missions by moving massive tonnage to GEO and beyond. I mean, that's the bottom line. Routine, safely, efficiently. I mean, that's really pretty neat. We've got some very, very good positive vibes on the whole thing. Well, why do I specify the modern day space elevator? David Rate wrote a paper for the Quest magazine that defined 8 specific architectures, starting with Tiakowski way back when, going through Brad Edwards a few times, then going beyond there. We've had 8 distinct architectures. Well, this one, the modern day space elevator, is ready to start. All we need is money to fund the engineering development, and we can get going. Now, we have a lot of questions. Okay, we got more questions than we have answers. But that's what happens when you have a mega project. So what we want to do is have a modern day. I like that terminology. It says we've made some progress in the last 25 years. Now, I am for any tether material that works, okay? I know there are people that say nanotubes work. Let's keep supporting them. But we right now in ISEC are kind of focusing with our help from Adrian Nixon and a few others at looking at the new two-dimensional materials. And I love this image that Adrian gave me on the lower right, which says the tether is kind of shiny and we can see it all the way up to 100,000 kilometers. Okay, the benefits of a permanent transportation infrastructure. That's the difference. We're putting a bridge across a river. It's permanent, daily routine, et cetera, et cetera. I've talked about some of these, but let's talk about daily to Mars. Everybody has always had a restriction of every 26 months we send a flotilla to Mars because you can't send them with minimum energy trajectories. And by the way, that's what rockets use, minimum energy trajectories. You can't send them but every 26 months. The students at the Arizona State University did a study for us called we wrote up the study called the Space Elevators are the Transportation Story of the 21st Century. But they talked about how they can depart every day. Now, some of them are 61 days long. That's the fastest. And some are 400 days long. But you could send your nails and hammers on the 400 days and send pizza on the 61 days. So the benefits of transportation infrastructure are remarkable. The operational configuration that I see in the future, obviously not the first one or two, but when we get an operational configuration of 3 galactic harbors, which each have 2 space elevators, then we're going to have a very productive capability to put mass up into space. Go to Mars, go to the outer planets, support GEO beautifully for like space solar power, stuff like that. In our study on the transportation system of the 21st century, which is in our body of knowledge on our website, we show the flow of mass depending on the improvement of your space elevators from initial operating capability to full operational capability from 1 to 6 and then growing up from 6 space elevators to 12. So you really can move mass. Why is that? It's a stinking bridge. That's all it is. You build up the bridge, you put a bigger truck on it. That's as simple as it gets. Okay, this is my pretty little 3 picture circles for going to Mars. Day releases, 61 days, massive movement. Basically, I believe we want to do the dual space access concept with rockets and space elevators to Mars. Let people go on rockets and we'll send the mass. It's that simple. Okay, the students even came up with a bus schedule. Can you imagine that? A stinking bus schedule to Mars. You know, the bus schedule today is every 26 months, send as many spacecraft as you can. But, you know, this comes up with every day of the year. You can just ship it. Benefits, move it faster. You go up the tether, you can go fast. If you go to 163,000 kilometer, you can leave the solar system without rockets. It's got that much velocity around the Earth. It's amazing. Okay, value proposition, we assemble at the top. Think of it this way. If you wanted to put a starship, galactic starship on the top of our apex anchor, we can bring up 14 metric ton components and build whatever we want. Now, yes, I know all the engineers start saying, well, you get a big mass up there, you got to have a heavier tether. Of course you do. But those are all concepts of how you can do it. But the point is you move a bunch of mass up to the top of the space elevator and you assemble something. And then here's the secret. You release it at very high velocity. It goes to Mars without any stinking rockets. Oh, you do need rockets to slow down rendezvous with Mars. But the point is, it can really get there fast because of the inherent velocity. Okay, 70% I told you earlier is our goal, but let's compare it to rockets. The rocket equation is the dumbest thing. The use of rockets for lifting stuff, what a dumb idea. We put 0.5% of the mass that was in Apollo 11 on the pad to the surface of the moon. FedEx would not take that job. But anyway, the point is we consume everything. Now, Mr. Musk is doing a fantastic job. Mr. Bezos right behind him. Reusability, multiple use of the launch first stage, all that. They're doing superb job, and I applaud them all. They still don't get more than 2% to geosynchronous. 1.5% to the surface of the moon. Okay, so what are we waiting for? Holy Toledo, we've got so much going on. We should be out there talking about why space elevators, because they have so much to offer. Unmatched efficiency, unmatched mass movement, apex anchor assembly. Rockets, you go up to 100,000 kilometers and you start trying to assemble stuff, it all moves away from you. It's all in orbit, man. It goes in all kinds of directions. And it's going to Mars at that altitude. So, having an assembly block at the top of the space elevator is really a brilliant idea. Okay, I mentioned the body of knowledge, and I want to make sure everybody understands this. We have had tremendous growth, and Dr. Edwards started it off, and I don't want to undervalue his. He did a spectacular job of getting us going. And then he helped us get going, ISEC get going, and I was talking to him and Ted Seaman, and we came up with the idea of doing studies every year, similar to the International Academy of Astronautics. That's where I got the idea. I've worked on some IAA studies. And so we started doing a study a year. Well, what this did is it focused us, a small group, 5 to 10, focused us every year on a topic, and we had to think of it. Now, here's the critical thing. We created because nobody had else gone there. We went where nobody else had gone. Think of the green road to space. Who came up with that silly terminology? Apex Anchor. We just finished the story of the Apex Anchor and did a report on it. We put in 11 separate, distinct missions that can be done at the Apex Anchor that essentially can't be done elsewhere. Like, here's the one. Oh, by the way, I've been working 10 hours today on a stinking paper for the IEC. The topic is planetary defense from the Apex Anchor. Now, think of it this way. We take up 14-ton payloads to the Apex Anchor top. We have a spaceport up there. We grab it, we store it, and then we assemble a big asteroid termination vehicle. And then what we do on our space elevator Apex Anchor is have stereoscopic views of the sun. So we catch the asteroids coming out of the sun. Now, why do we need to do that? Well, because most of the time those asteroids are identified after they go past the Earth. In other words, they miss the Earth. We never saw them coming. They were going away from us. Think about that a little bit. Asteroids are coming out of the sun and we never see them until they're past us. Why is that? Because the sun's really bright and we can't see anything. But if you have a baseline of 200,000 kilometers across and have your telescopes crossing in front of the sun, you can do some very nice blockage and you can catch those asteroids out of the sun early. So I just spent 10 hours doing that today. So that, we generated that idea of planetary defense at the Apex Anchor because of that study we did. And so we've got all kinds of stuff, 2 IAA studies. Obayashi Corporation came up with a superb look at larger space elevator with humans. The other thing is we've had some very nice contacts with the British Interplanetary Society. And what I like to do today is give a little challenge to everybody. I don't belong to IEEE or, well, I do AIAA, but a whole bunch of other things, American Medical Society, all that kind of stuff, the Mars Society, the Moon Society. What we need to do is publish then their documents also. So what I'd like to do is challenge anybody on the conference to come up with an idea of how you can contribute in the society you're joined, you're part of, other than ISEC, of course. And I would help you come up with a topic and develop a paper for one of your magazines in one of your societies. It's a pain in the rear end to do an article, but it's fun to do it. It's creative and you can have fun doing that stuff. But we've had a very good success with the British Interplanetary Society. And here's one that just came out. My wife was the lead on this one. She does all the editing and everything else and comes up with some good ideas.
Pete, you have a minute.
Pardon?
You have 1 minute.
Oh, you mean you didn't give me your credit from your early part?
No.
Oh, okay. That's okay. You want to be ahead. Okay, I'll get done here. reference missions. These are my guesses at what we have to support in the future. Mr. Musk wants 1 million tons on Mars. The Space Solar Power wants 3 million tons in geosynchronous, stuff like that. So why are we doing this? Because we must. It's in our soul. We must build space elevators. These are elegant answers. We have unmatched efficiencies. We got unmatched velocities, and we move a lot of mass. I mean, we are the green road to space, so we really are the answer. And so I'm a backup. Look at that. I gave you 45 seconds back there, Dennis.
Well, this might be obvious, but this will be just kind of a general question. It's not a technical question. What do you believe has to change in the paradigm, the philosophy, whatever it is, of the current system in which everyone's so enthusiastic about these large payload reusable rockets, which will play their role as you've described? How does the industry shift to acknowledge, to accept space elevators? And I guess the conclusion of that statement is, or that question is it one of those you have to build it and then they will come? In other words, does something have to be built before people actually recognize the value?
My quick answer is two parts. The first is I think what we need to do is get somebody of prominence to say we need a plan B. And we can just call it a plan B as a backup approach to taking mass to orbit, and just claim we're doing mass. Let's not go to the human question at this point. And we'll do that, and then get initial funding for the first 5 years, maybe $1 billion to do that. And then we can present our case with real engineering data. And I think that will work. That's been my plan for the last year, and it's kind of failed, as you know. But that's the approach I'm taking. The other one is kind of an interesting thing. My brother came up with this, and I'm trying to set it up. I was going to propose it to the board meeting sometime in the near future. What we need to do is get up an MOU between organizations that say the space elevator is a really great concept. No commitment of money or anything else, but I sign my name in company that says space elevators are valid and have a great potential. And just an MOU, no money, no nothing, just get a bunch of MOUs so that we can start getting the word around. So those are the two ideas I have off the top of my head. Then we have a Stephen
Yeah,
Knudsen.
has there been, yeah, has there been any progress in what to do if there's a small break or a defect in the elevator since like 2008? Have you come up with some ideas for
Yes,
mitigating breaks?
yes, there's been tremendous progress you haven't been keeping up with, obviously, and not reading our newsletter. It turns out we're focusing on two-dimensional materials, and we're making a lot of progress on that recently. There was a 1,000-meter run, not up to our snuff for our materials for a space elevator, but a two-dimensional material of 1,000 meters at like a meter per minute. And so we're making great progress there. Well, in parallel with the manufacturing, flow of a sheet, they're also doing science questions. And one of the questions is, how does the material react to small punctures and stuff like that? We have a lot of that data in our newsletter. If you just go newsletter on our website, go to the materials page. It's usually like 8.5 by 11 page of material every month. And it talks about, breakage, tears, holes, all this kind of stuff in two-dimensional materials. And it's really quite remarkable and positive for the operations, not negative. They
Thank you.
found it, I don't want to go too far because I'm not an expert. We are going to have some discussions on that. I think today, isn't Adrian on today? So
Adrian's on tomorrow.
on tomorrow. So tomorrow you're going to have a very nice presentation by Adrian Nixon on materials, and he'll be covering those specific questions.